Hello there, and welcome back to the Sleepy Nova Chronicles. Right now, above you, something is being assembled. Not by any hand. Not by any machine. Not by any process that announces itself with sound or heat or visible motion. Directly above the roof of whatever building you are in tonight, above the ceiling, above the rafters, above the tiles or the concrete or the insulation and the cold air between you and the open sky, water is moving. Not falling. Not pooling. Moving upward, invisibly, as vapor, rising in currents of warm air that climb away from the surface of the earth with the quiet certainty of something that has been doing this, without interruption, for 4.5 billion years. And somewhere up there, at an altitude of between 1 and 12 kilometers above the ground, at a height where the air is thin enough that you would lose consciousness within minutes if you were exposed to it without protection, that invisible water vapor is meeting cold air. And when it meets cold air, something happens that is so ordinary that most people have stopped seeing it, and so extraordinary that the more carefully you look at it, the more it refuses to resolve into anything simple. It becomes a cloud. Not the kind you imagine when someone says the word casually. Not a soft, decorative thing drifting across a postcard sky. Not a background detail in a photograph of something else. The clouds we are going to spend this quiet hour with tonight are machines. They are the largest, most powerful, most ancient manufacturing systems on the surface of this planet, each one a self-organizing engine of physics and chemistry, assembling and disassembling itself continuously, processing millions of tons of water every hour, regulating the temperature of the entire planet, generating electrical charges powerful enough to split trees, and doing all of it in complete silence from the perspective of anything watching from below. You have looked at clouds your entire life. You have never seen what they actually are. Detectives looking at the physics of cloud formation revealed something that stops most people the first time they encounter it clearly. A cloud is not made of water vapor. This is the first misconception to release tonight, gently, like opening a hand. You cannot see water vapor. It is invisible. What you see when you look at a cloud, that white or grey or charcoal mass hanging in the sky with a weight and a presence that painters have spent centuries trying to capture, is not gas. It is liquid. It is millions upon millions of individual water droplets, each one so small that it weighs almost nothing, each one suspended in the air by the upward movement of the atmosphere around it, each one a perfect sphere of liquid water roughly 1/100th of a millimeter across. 1/100th of a millimeter. A human hair is approximately 70 micrometers wide. A single cloud droplet is between 5 and 20 micrometers in diameter. You could fit 4 cloud droplets side by side across the width of a single human hair, and you would still not be able to see any of them individually with the naked eye. And yet a single cumulus cloud, the rounded, cauliflower-shaped cloud that appears on warm afternoons, the kind a child draws when asked to draw a cloud, contains approximately 500 million liters of water. 500 million liters. The average bathtub holds around 300 liters of water. A single ordinary cumulus cloud holds the equivalent of approximately 1.5 million bathtubs, filled to the rim, suspended in the sky above your head. It does not fall. This is the second fact that tends to arrest people when they meet it directly. The cloud contains an almost incomprehensible quantity of liquid water, and it does not fall. The droplets are too small, and the air is moving too continuously upward for them to descend. Each droplet is held aloft by the very atmospheric motion that assembled the cloud in the first place. The cloud is not a static object sitting in the sky. It is a dynamic balance between gravity pulling each droplet down and warm air pushing each droplet up, maintained continuously, adjusted moment by moment, never quite stable and never quite collapsing, like a conversation between two forces that have been having the same argument since the Earth first had an atmosphere to argue in. This is the monster at the heart of cloud science, not in its appearance, but in its function. The cloud is a processing engine so vast and so continuous that all of human industrial output, all the manufacturing and energy generation and water processing that human civilization has ever produced, fits comfortably inside a single afternoon's work of a moderately active global weather system. The sky is not empty. It never was. Consider what is happening above you right now, tonight, while you are still and the world outside your window is dark, and the clouds you cannot see are doing their work in the cold air above. At any given moment, the Earth's atmosphere holds approximately 12,900 cubic kilometers of water in vapor form, water that has evaporated from oceans and lakes and rivers and the surfaces of leaves and the breath of animals, risen into the sky, and is currently somewhere in the process of becoming, or remaining, or dissolving back from, a cloud. 12,900 cubic kilometers. If you took all of that water and poured it onto the surface of the Earth at once, it would cover every continent on the planet to a depth of approximately 25 millimeters, a layer roughly as thick as the width of your thumb, spread uniformly across every landmass on Earth simultaneously. That water is above you right now, cycling, processing, being assembled into cloud droplets and released as rain and evaporated back into vapor and assembled again, in a loop that has been running continuously since the first oceans formed on the cooling surface of the early Earth, approximately 4 billion years ago. The water in the cloud above you tonight has been through this cycle an uncountable number of times. It has been ocean. It has been rain. It has been ice at the poles and river and groundwater and the interior of a living cell. It has been breathed out by organisms that no longer exist. It has been locked in glaciers for 100,000 years and then released in a single summer. It has been every form that water can take, on a planet that has been cycling its water without interruption for longer than complex life has existed. And tonight, some of it is a cloud, hanging in the cold dark above your roof, assembling itself from vapor around particles so small they have no business existing at all. Particles of dust and sea salt and pollen and smoke and the microscopic shells of ocean organisms, each one acting as a seed around which a water droplet can form, each one a nucleus for the cloud's continuous act of self-assembly. You breathed some of those particles in today. The dust that seeded the clouds above you tonight, the aerosol particles that gave the water vapor something to condense around, that made the cloud possible, came from the same air you moved through. Some of it came from the ground beneath your feet. Some of it came from the ocean, carried inland on wind. Some of it came from a fire burning on a different continent, or from the surface of a road, or from the dried skin of a flower that finished blooming 2 weeks ago. The atmosphere is not selective. It carries everything the surface releases, upward into the cold, where the water finds it and wraps around it and becomes something visible. The cloud above you is made, in part, from the world you inhabited today. Detectives looking at the aerosol composition of clouds above major cities revealed that cloud droplets forming over urban areas contain measurable quantities of material specific to that city. Particles from its roads, its industry, its cooking, its breath. The cloud is a record of the surface below it. It carries the chemical signature of whatever the wind passed over on its way up. A cloud forming above a forest smells different, has a different chemical composition, than a cloud forming above an ocean or a desert, because the aerosol particles it condensed around came from different sources, and those particles are still inside the droplets, sealed in liquid water, being carried across the sky. The cloud remembers where it came from, and what it is building, up there in the dark above you, is something that will return to the surface transformed. The water that rises as vapor and assembles into cloud droplets and eventually falls as rain is not the same water that left the surface. It has been filtered, processed, exposed to ultraviolet radiation and chemical reactions and the mixing of air masses from different latitudes. It has picked up and deposited particles. It has exchanged gases with the atmosphere. It arrives back on the surface slightly different from how it left, slightly altered, slightly refreshed, carrying traces of its journey in its chemistry, the way a traveler carries traces of the places they have been. This is the oldest recycling system on Earth, older than any organism, older than any ocean. running continuously since before the first cell ever divided in the warm shallows of the early Earth, before there was anything alive to drink the rain or shelter from the cloud, or lie still in the dark and wonder what the sky was doing. If you find these quiet journeys useful, these slow hours of science and deep time, and the feeling that the world is larger and older and more patient than whatever occupied your mind today, then I would gently invite you to subscribe, or to leave a thought below about which part of this stays with you. It helps other people who are lying in their own darkness, also trying to let the day go, find their way here. But for now, there is nothing you need to do. Allow your shoulders to soften. Let the weight of your body settle into whatever is beneath you. Let your breathing find its own depth, not controlled, not adjusted, just allowed to move at the pace it chooses. Somewhere above you, in the cold air beyond the roof, water is assembling itself around particles of dust into droplets too small to see, building something that will be gone by morning, building it anyway, with no awareness of impermanence, with no hesitation at the scale of the task. The sky has been doing this every night of your life. It will do it tonight. Let's begin. To understand what a cloud actually does, you have to start somewhere most people never think to look. Not in the sky. Underground. Specifically, underneath the ocean, where sunlight drives the first act of the most consequential physical process on the surface of this planet. The ocean covers approximately 71% of the Earth's surface. At any given moment, the top layer of that ocean, the warm, sun-heated surface water, sometimes no deeper than the first few meters, is evaporating. Silently, continuously, at a rate that, if you could see it happening, would look less like a gentle mist rising from a lake on a cool morning and more like a planet exhaling. The ocean breathes water into the sky at a rate of approximately 430 cubic kilometers per day. 430 cubic kilometers. Every day. To hold that number in your body rather than just your mind, imagine a cube of water with sides approximately 7.5 kilometers long. 7.5 kilometers in every direction, filled completely with water. That is roughly the volume of water the ocean surrenders to the atmosphere every single day, not through any dramatic event, not through storms or catastrophe, but simply through the quiet, continuous action of sunlight on water. The sun hits the ocean surface. The water molecules at the very top absorb that energy. They move faster. The fastest ones escape the surface entirely, detach from the liquid body of the ocean, and rise into the air as individual molecules of water vapor, invisible, weightless, carried upward by warm air currents that climb away from the sun-heated surface below. This is the beginning of every cloud that has ever existed. Not the dramatic part, not the towering thunderhead or the dark wall of an approaching storm. The beginning. The invisible, unremarkable, perpetually occurring evaporation of ocean water into air, the first step in a process that will, over the next several days, carry that water thousands of kilometers from where it started, assemble it into visible cloud formations above land and sea, and eventually return it to the surface as rain or snow or the thin layer of morning dew that collects on a car roof overnight. The water vapor rises, and as it rises, the air around it cools. This is the physical law that makes clouds possible, and it operates with the impersonal precision of mathematics. For every 100 meters of altitude gained, the temperature of the surrounding air drops by approximately 1 degree Celsius. 1 degree per 100 meters. This rate, called the environmental lapse rate, is not an approximation or an average. It is a physical consequence of the relationship between air pressure and temperature. As air rises and pressure decreases, the air expands. Expanding air cools. The cooling is automatic, continuous, and exactly predictable. At some altitude, the specific height depending on the temperature and humidity of the air on that particular day, at that particular location, the rising air cools to the point where it can no longer hold all of its water vapor in gaseous form. This threshold has a name. It is called the dew point. And when rising air reaches its dew point, The water vapor it carries does not simply stop being vapor. It transforms. It condenses. Around the aerosol particles we encountered in the opening of tonight's journey, the dust and sea salt and pollen and smoke particles suspended in the lower atmosphere, individual water molecules begin to attach. Then more molecules attach. Then more, building outward from the particle nucleus in a sphere of liquid water that grows from nothing to a droplet 5 to 20 micrometers across in a fraction of a second. Multiply this event by trillions of simultaneous condensation reactions happening at the same altitude across an area of sky perhaps hundreds of kilometers wide, and the result is visible from the ground. The cloud base forms. It forms at a specific altitude, the same altitude everywhere across the cloud's base. Because the dew point is reached at the same height everywhere, the air has the same temperature and humidity. This is why the bottoms of clouds are flat. Not approximately flat. Geometrically, precisely, remarkably flat. A horizontal plane marking the exact altitude where the physics of condensation switched on, as clean and deliberate looking as a line drawn with a ruler across the sky. The flat base of a cloud is one of the most elegant visible demonstrations of a physical law that exists in the natural world. Every time you see it, you are seeing the dew point made visible. You are seeing the precise altitude, marked in water, where vapor became liquid. Above that flat base, the cloud builds upward. And this is where the scale of what the atmosphere is capable of begins to reveal itself fully. The engine driving the upward growth of a cloud is called convection, the movement of warm air rising through cooler air above it. Warm air is less dense than cool air. Less dense things rise. This is not a meteorological speciality. It is the same principle that makes a hot air balloon rise, that makes the air above a candle flame shimmer, that makes the top of a room warmer than the floor. Apply it to the atmosphere, at the scale of the atmosphere, and you get updrafts, columns of rising warm air that can carry cloud material upward at speeds that have no equivalent in everyday experience. Inside a mature cumulonimbus cloud, the towering, anvil-topped storm cloud that represents the atmosphere's most extreme expression of convective energy, updraft speeds can reach 270 kilometers per hour. 270. That is faster than a Formula One car at full racing speed on a straight. That is the speed of a high-velocity rifle bullet in its final deceleration. And it is not occurring in a wind tunnel or a specialized testing environment. It is occurring inside a column of condensing water vapor, tens of kilometers tall, directly above ordinary land or ocean, driven by nothing more exotic than the temperature difference between warm surface air and the cold upper atmosphere. The largest cumulonimbus clouds, the supercell thunderstorms that form over the central plains of North America and the tropical oceans, extend from a base at roughly 2 kilometers altitude to an anvil-shaped top at between 12 and 18 kilometers. 18 kilometers. The cruising altitude of a commercial aircraft is approximately 10 to 12 kilometers. The top of a mature supercell thunderstorm punches through the cruising altitude of a transatlantic flight and keeps going, extending several kilometers above it, into the lower stratosphere, where the cloud's upward growth is finally stopped not by a lack of energy, but by the temperature structure of the atmosphere itself, which becomes warmer with altitude in the stratosphere and refuses to let the rising air go any further. The cloud hits a ceiling made of warm air and spreads outward. This is what creates the anvil shape, the distinctive flat top that spreads horizontally for hundreds of kilometers from the storm's peak, recognizable from space, visible on satellite imagery as the signature of the atmosphere doing its most extreme work. The anvil is not a decoration. It is the signature of an updraft so powerful that it has run out of atmosphere to climb through. It is the mark left on the sky by a column of air moving at Formula One speed for a vertical distance of 16 kilometers, carrying millions of tons of water upward in the process. Detectives looking at the internal structure of supercell thunderstorms using radar and instrumented aircraft revealed something that reconfigures how you understand the sky above you on a stormy afternoon. Inside a mature supercell, multiple updraft and downdraft columns exist simultaneously, rotating around each other in a structure called a mesocyclone, a spinning column of air several kilometers wide, embedded within the larger storm, capable of generating winds that exceed 400 kilometers per hour in its most concentrated form. 400 kilometers per hour. That is the speed of a high-speed train traveling at its maximum designed velocity, occurring inside a column of rotating air above an ordinary field or suburb, driven entirely by temperature differences and the physics of rotating fluids. No fuel, no mechanism, no infrastructure. Just warm air, cold air, moisture, and the rotation of the Earth, interacting according to laws that have been operating since the planet first had an atmosphere, producing, on any given afternoon over the right landscape, an engine of rotating air more powerful than anything human engineering has ever deliberately constructed. This is the monster of the atmosphere, not in its appearance from a distance, which can be beautiful in a way that makes the danger hard to believe, but in its mechanical function. The supercell is a heat engine. It takes thermal energy from the warm surface below, converts it into kinetic energy through convection, processes millions of tons of water through its interior, generates electrical charges that discharge as lightning at a rate of approximately 40 to 50 lightning bolts per second across the entire planet at any given moment, and does all of this as a routine, unremarkable feature of the Earth's daily weather. 40 to 50 lightning bolts per second. Right now, as you lie still and your breathing slows and the night is quiet around you, the atmosphere is producing 40 to 50 lightning discharges every second somewhere on the surface of this planet. Each bolt carries an electrical charge of approximately 1 billion joules, enough energy to power a household for roughly a month, released in a channel of plasma approximately as wide as a thumb, heated in that instant to approximately 30,000 degrees Celsius. 5 times hotter than the surface of the sun. In a channel the width of your thumb. The sound that reaches you seconds later, the thunder, is the air around that plasma channel exploding outward as it is superheated faster than the speed of sound. The crack and rumble of thunder is a sonic boom, a shock wave propagating outward from a channel of air that went from ambient temperature to 30,000 degrees in less than a millisecond. You have heard this sound since childhood. You have sheltered from it. You have counted the seconds between the flash and the rumble to estimate how far away the storm was. You were counting the distance between you and a plasma channel 5 times hotter than the surface of the sun. But here is where the scale of cloud mechanics asks you to hold two things simultaneously: the violence of the extreme and the gentleness of the ordinary. Because the same physical processes that produce a supercell thunderstorm also produce the soft, diffuse layer of gray cloud that sits overhead on a winter morning and makes no sound at all. The same condensation physics, the same dew point, the same updraft mechanics, operating at a fraction of the energy, in an atmosphere that is stable rather than unstable, producing not a rotating column of 400 km/h wind, but a thin, even, quiet sheet of cloud that softens the light and makes the world feel smaller and closer and more contained. Meteorologists call this stratus, from the Latin word for layer. Stratus clouds form when warm, moist air moves horizontally over a cooler surface, the cold ocean or snow-covered ground, or simply the cooler air of a different air mass, and cools gradually, without the dramatic vertical instability that drives convective clouds. Instead of building upward in towers, the condensation spreads horizontally, forming a blanket that can extend for thousands of kilometers in every direction, a continuous sheet of cloud at a single altitude, sometimes only a few hundred meters thick, blocking the sun without drama, muffling sound slightly, making the light diffuse and even and without shadow. This is the cloud of quiet days, of slow mornings, of the kind of afternoon that does not demand anything of you. Detectives looking at the global distribution of cloud cover revealed that at any given moment, approximately 67% of the Earth's surface is covered by cloud. 2/3 of the planet, at this moment, is under cloud. The clear skies you see on a fine day are the exception. The default state of the Earth, from the perspective of space, is partial to significant cloud cover. A planet wrapped, more often than not, in the white and grey and brilliant white of its own water cycle, perpetually processing, perpetually assembling and dissolving, the atmosphere doing its continuous work of moving energy and water from where there is too much of each to where there is not enough. The cloud above you tonight is part of this. Part of the 67%. Part of the continuous planetary process that has been running since before the first rain fell on the cooling surface of the early Earth, 4 billion years ago, before there was soil to receive it or roots to drink it or any living thing to look up and notice the sky changing. The cloud does not know you are beneath it. It does not need to. It simply continues, assembling its droplets around its dust particles at its dew point altitude, maintaining its balance between gravity and updraft, processing its water and its energy and its electrical charge, doing the work it has always done, in the dark above the roof of whatever building you have chosen for your rest tonight. The sky is working. It has always been working. And you are beneath it, still, held by the same gravity that holds every droplet in suspension, subject to the same atmospheric pressure that makes the physics of condensation possible, breathing the same air that carries the water vapor upward to the cloud base. You are part of the system. You always have been. A raindrop does not fall the way most people imagine. The image most people carry, a teardrop shape, pointed at the top, rounded at the bottom, falling in a clean vertical line from cloud to ground, is wrong on every count. A falling raindrop is not pointed at the top. It is not a teardrop at all. Detectives looking at high-speed photography of falling water revealed that a raindrop in free fall is shaped like a hamburger bun, flattened on the bottom by air resistance, domed on top, slightly wider than it is tall, wobbling as it descends through air that pushes against it from below with a force that continuously deforms its surface. The larger the drop, the more pronounced the flattening. The largest raindrops, those with a diameter approaching 5 millimeters, roughly the size of a small pea, are so flattened by air resistance that they look less like drops and more like tiny parachutes, their bottoms concave, their edges curling upward as the air resistance hollows them from below. And then they break apart. A raindrop larger than approximately 5 millimeters cannot survive the aerodynamic forces acting on it during its fall. The air resistance hollows the bottom further and further until the drop inverts, destabilizes, and shatters into dozens of smaller droplets that continue falling separately. The largest raindrops in any storm are continuously breaking apart into smaller ones, which grow by collision with other droplets, which then grow large enough to break apart again. Rain is not a simple delivery of water from cloud to ground. It is a cascade of continuous fragmentation and collision, a chain reaction of droplets breaking and merging and breaking again, all the way from the cloud base to the surface. The raindrop that lands on your skin tonight arrived there through a process of continuous transformation that began as a water vapor molecule rising from the ocean surface, proceeded through condensation around a dust particle at the dew point, continued through dozens of collisions with other droplets inside the cloud as updrafts carried it upward and downdrafts pulled it down, grew large enough to finally overcome the updraft and begin its descent, broke apart and reformed multiple times during that descent, and arrived at your skin as something entirely different from what it started as. The same water, completely transformed. And what it does when it arrives is as important as everything that happened before. Rain does not simply wet things. Rain reshapes the world. The impact of a single raindrop on bare soil, that small, soft percussion you hear during the first minutes of a shower on dry ground, dislodges soil particles with a force that seems impossible given the size of the drop. High-speed photography reveals that a raindrop striking a dry soil surface at terminal velocity, approximately 9 meters per second for a medium-sized drop, excavates a small crater and throws soil particles outward in a corona of ejected material, some particles traveling horizontally more than 30 centimeters from the point of impact. 30 centimeters from a raindrop. Multiply that by the number of raindrops falling in a moderate rainfall event, approximately 2,000 drops per square meter per minute during typical mid-latitude rain, and you begin to understand why rain is among the most powerful erosive forces on the surface of the planet. 2,000 impacts per square meter per minute, each one excavating its small crater, each one throwing particles outward, each one contributing to the slow, patient, relentless process of moving material from higher ground to lower ground that has been reshaping the continents since the first rain fell on the cooling surface of the early Earth. The Grand Canyon was made by water. Not quickly, not in a single catastrophic flood, though floods contributed. Mostly by the patient, daily, unremarkable process of rain falling on the Colorado Plateau and running off into streams and rivers that carried dissolved and suspended rock material toward the ocean, cutting downward through the plateau at a rate of roughly 100 to 300 meters per million years. The Colorado River has been cutting the canyon for approximately 5 to 6 million years. The result is a chasm approximately 446 kilometers long, up to 29 kilometers wide, and approximately 1.5 kilometers deep at its deepest point. 1.5 kilometers deep, carved by water, by rain that fell on a plateau and ran downhill because gravity insisted. A raindrop falling on the rim of the Grand Canyon tonight is continuing the same process that carved the canyon. It is contributing, in its infinitesimal way, to the ongoing erosion of the Colorado Plateau. It will carry a few dissolved mineral molecules to the river below. The river will carry them toward the ocean. The canyon will be, in 10 million years, slightly wider and slightly deeper than it is tonight. Rain does not hurry. It does not need to. But rain is only one form of the cloud's delivery. At higher altitudes, at higher latitudes, in winter air cold enough to freeze water before it reaches the ground, the cloud assembles something different. Something that has no parallel in the rest of the water cycle for the elegance of its construction. Snow. A snowflake begins as a single water molecule attaching to an ice nucleus. A particle, often a fragment of clay mineral or a biological particle like a fragment of leaf or a bacterial cell, around which water vapor can deposit directly as ice without passing through the liquid phase. This process, called deposition, builds ice crystals one molecule at a time, with each new water molecule attaching to the growing crystal in a position dictated by the hexagonal geometry of ice's molecular structure. Ice is hexagonal at the molecular level. Every water molecule that joins a growing ice crystal must fit into the hexagonal lattice. This constraint, this molecular geometry operating at a scale a billion times smaller than anything you can see, is the reason every snowflake has 6 sides. Not approximately 6. Exactly 6. The hexagonal symmetry of ice is perfect, and it propagates from the molecular scale to the visible scale without variation, producing the 6-fold symmetry visible in every snowflake that has ever fallen. Detectives looking at the growth patterns of individual ice crystals under microscopes revealed something that has fascinated physicists for centuries and has never been entirely explained. Each of the 6 arms of a growing snowflake grows independently. There is no communication between one arm and another, no coordinating mechanism, no blueprint being followed. Each arm simply responds to the local conditions of temperature and humidity it encounters as it grows. And yet the 6 arms of a snowflake are, to a degree of precision that challenges explanation, identical to each other. The symmetry is not imposed from outside. It emerges from the physics of the situation. Each arm encounters identical conditions because each arm is the same distance from the center of the crystal, experiencing the same temperature and humidity at the same moment. The snowflake is a record of the atmospheric conditions it grew through, each variation in its branching pattern a record of a microchange in temperature or humidity at the precise moment that part of the crystal was forming. No 2 snowflakes follow exactly the same path through exactly the same atmospheric conditions. No 2 snowflakes are identical. Every snowflake that has ever fallen, across every winter in 4.5 billion years of Earth history, across every storm on every continent, across every ice age and every glacial period and every ordinary December night, has been unique. The number of snowflakes that have fallen since the Earth first had winters is estimated at approximately 1 times 10 to the power of 34. That is a 1 followed by 34 zeros. A number so large that it exceeds the estimated number of atoms in the planet Earth by many orders of magnitude. Every single one of those snowflakes was different from every other one. Every one carried in its branching geometry a unique record of the specific path it took through the specific atmospheric conditions of the specific moment it formed. And every one melted, or did not melt, because in some places, under some conditions, snow that falls does not return to liquid and does not evaporate back into the atmosphere. In some places, snow accumulates, layer upon layer, year upon year, compressing under its own weight, the air squeezed out of it, the crystal structure of the snowflakes collapsing into denser and denser ice, until the accumulated mass of years of snowfall becomes something that moves. A glacier. A glacier is a cloud in its slowest possible form. Water that evaporated from the ocean, rose into the atmosphere, condensed into cloud, fell as snow, and then, instead of returning immediately to the ocean, stayed. Accumulated. Compressed. Began, under the pressure of its own enormous weight, to flow. Not quickly. Not in any way that a human observer standing beside one could perceive directly. A typical alpine glacier moves between 10 centimeters and 1 meter per day, roughly the speed of the minute hand of a large clock, if you could watch it continuously. But a glacier does not need to move quickly to do extraordinary work. The largest glacier on Earth, the Lambert Glacier in Antarctica, is approximately 100 kilometers wide, 400 kilometers long, and in places more than 2.5 kilometers thick. It contains enough ice that if it melted entirely, it would raise global sea levels by approximately 1 meter. One glacier, one of thousands currently existing on the planet, most of them in Antarctica and Greenland, collectively holding approximately 69% of the world's fresh water in solid form. Water that evaporated from the ocean, rose as vapor, condensed as cloud, fell as snow, and has been sitting in frozen accumulation for periods ranging from decades to millions of years. The ice at the bottom of the East Antarctic ice sheet, the deepest, oldest ice on the planet, is approximately 2.7 million years old. 2.7 million years ago, the ancestors of modern humans had not yet appeared. The water in that ice evaporated from an ocean that was already ancient. It rose as vapor. It condensed as cloud. It fell as snow above Antarctica. And it has been there, compressed and frozen, ever since, waiting, as all water eventually waits, for the conditions that will allow it to move again. This is the patience of the cloud's legacy. Not just the immediate delivery of rain that carves canyons and feeds rivers and falls on your skin during a summer storm. The long patience of water that chose the slow path, the path through snow and glacial compression and million-year storage in ice, before returning to the ocean. Water that left the ocean surface as vapor, became cloud, became snowflake, became glacier, and will not return to liquid for another million years. Your body is mostly water. Approximately 60% of your body weight, right now, is water. Water that you have drunk and eaten and absorbed. Water that is circulating through your blood and filling your cells and forming the fluid in your joints and the moisture in your breath. Some of that water, a small but measurable fraction of it, has been through the full cycle, has been ocean, has been cloud, has been rain and river and groundwater and plant and animal and food and drink, and now you. Some of the water in your body tonight has been a snowflake, possibly many snowflakes, across many winters, across many centuries of cycling through the atmosphere and the ocean and the land and the living things that drink from rivers fed by glacial melt. The specific water molecules in your body right now have no memory of their journey. They carry no record of the clouds they passed through, or the snowflakes they briefly formed, or the glaciers they spent 100,000 years compressed inside. But the journey happened, is happening, will continue after you return the water to the world through your breath and your sweat, and eventually, across a longer timeline, through the complete dissolution of your body back into the soil and the water table. You are a temporary container for water that is older than life. And tonight, while you are still, that water is doing what it always does inside a living body, cycling, processing, maintaining the conditions necessary for the quiet, continuous biological work that does not require your attention or your awareness. Your cells are mostly water. Your thoughts are conducted through water. The electrical signals in your nervous system travel through ion channels that depend on the presence of water to function. You are, in the most literal sense, a weather system in miniature, processing water, exchanging gases, maintaining temperature, doing the same fundamental work the cloud does, at a scale that fits inside a human body instead of a continent. The cloud above you is not separate from you. It is the same process, the same physics, the same patient cycling of water through every form it can take, driven by the same solar energy that evaporated the ocean this morning and will evaporate it again tomorrow, and has been evaporating it every day since the Earth first had oceans to evaporate. Outside your window tonight, the cloud is doing its work in the dark. The droplets are colliding and merging. The ice crystals are growing their 6 identical arms. The rain is falling somewhere, reshaping something, carrying something dissolved from somewhere higher to somewhere lower. The snow is accumulating somewhere cold, building toward the glacier that will form in 10,000 years, storing the ocean's water in frozen patience above a landscape that does not yet know it will one day be carved by meltwater. All of it continuous, all of it patient, all of it happening in the dark while you rest. Your breathing has slowed. The day has moved further away. The thoughts that were present at the beginning of this journey have settled, the way sediment settles through still water. Not gone, just lower, quieter, no longer moving at the surface. The cloud does not resist the process of becoming rain. It does not hold on to its droplets when the conditions for precipitation arrive. It releases. It gives back what it gathered. It completes the cycle without hesitation, without calculation, without any awareness that what it is doing is, in the end, the most generous act the atmosphere performs, returning to the ground the water the ground gave up, transformed, processed, ready to begin again. Let that be the last thought of this movement. The cloud gives back what it gathered. It always does. The cloud is not neutral. This is the fact that took the longest to understand. For most of human history, for all of it, in fact, until less than a century ago, the sky was treated as a backdrop, a setting, the thing that weather happened in front of, rather than the thing that drove the conditions of everything below it. Clouds were observed, painted, named, feared, celebrated, navigated by. But they were not understood as active participants in the temperature of the planet. They were not understood as a feedback mechanism, as a system that responds to changes in the climate below it in ways that can either amplify those changes or dampen them, depending on which type of cloud forms, at which altitude, over which surface, at which time of day. They were not understood as a thermostat. Detectives looking at the relationship between cloud cover and planetary temperature revealed something that restructured climate science when it emerged clearly, and that remains, even now, one of the most complex and consequential unsolved problems in Earth system science. Clouds do 2 opposite things to the planet's temperature simultaneously. They cool it, and they warm it. Which effect dominates depends on a set of variables: cloud altitude, cloud thickness, cloud droplet size, the surface below the cloud, the angle of the sun, that interact with each other in ways so intricate that the world's most powerful supercomputers, running the most detailed climate models ever constructed, still cannot predict with certainty exactly how clouds will respond to a warming world. This is not a small uncertainty. It is the largest single source of uncertainty in climate projections. Not carbon dioxide levels. Not ocean circulation. Clouds. To understand why, you have to hold 2 things in your mind at the same time. The first thing is this. During the day, clouds reflect sunlight. The white surface of a thick cumulus cloud reflects approximately 90% of the solar radiation that strikes it back into space, the same percentage reflected by fresh snow. 90%. The solar energy that would have reached the ground and warmed the surface never arrives. It bounces off the top of the cloud and travels back into space, carrying its heat with it. This is the cooling effect. A planet with more cloud cover reflects more solar energy and stays cooler. A planet with less cloud cover absorbs more solar energy and warms. The average albedo of the Earth, the percentage of incoming solar radiation that the planet reflects back into space, is approximately 30%. Of that 30%, approximately 2/3 is reflected by clouds. Remove the clouds entirely, and the Earth's albedo drops dramatically. The planet absorbs significantly more solar energy. Global temperatures rise. Clouds cool the planet by reflecting the sun. The second thing is this. At night, and during the day, for clouds that are high and thin, clouds trap heat. They absorb the infrared radiation emitted by the warm surface of the Earth and re-emit some of it back downward, preventing it from escaping to space. This is the same greenhouse mechanism by which carbon dioxide and water vapor warm the planet. Clouds, particularly high-altitude clouds called cirrus, are among the most effective greenhouse agents in the atmosphere, thin enough to let solar radiation through during the day, but effective enough at trapping outgoing infrared radiation that their net effect on temperature is warming rather than cooling. High, thin clouds warm the planet. Low, thick clouds cool it. And the balance between these two effects, the competition between the reflective cooling of low clouds and the greenhouse warming of high clouds, determines, more than almost any other single factor, the temperature of the surface of the Earth. The entire history of the planet's climate, across 4.5 billion years of ice ages and warm periods, and the gradual evolution of an atmosphere capable of supporting complex life, has been shaped in part by shifts in this balance. By changes in which types of clouds formed, at which altitudes, over which surfaces, driven by changes in ocean temperature and atmospheric circulation, and the distribution of continents across the planet's surface. The cloud is not a passenger in the climate system. It is one of the drivers. And here is where the catastrophe arrives. Not as a single event, not as a dramatic rupture in the fabric of the sky, but as a feedback loop. A self-reinforcing cycle that begins quietly and accelerates. The ocean warms. Warmer ocean water evaporates faster. More water vapor enters the atmosphere. More water vapor means more clouds, but not necessarily more of the right kind of clouds, and not necessarily in the right places. Warmer surface temperatures also change atmospheric circulation, the patterns of rising and falling air that determine where clouds form and where they don't. Some regions that currently have abundant low-level cloud cover may lose it as the atmosphere warms, and the conditions that produce those clouds shift. And low-level cloud cover, as we have established, is one of the primary mechanisms by which the Earth cools itself. Lose the low clouds. The planet absorbs more solar radiation. It warms further. The ocean warms further. The conditions for low cloud formation deteriorate further. The planet absorbs more solar radiation still. This is a positive feedback loop. Positive not in the sense of beneficial, but in the mathematical sense. A loop in which the output reinforces the input, in which the system amplifies rather than dampens the initial change. Climate scientists call this cloud feedback, and it is the reason the uncertainty range in climate projections is as wide as it is. If the warming world produces more high clouds and fewer low clouds, the feedback is positive. Warming begets more warming. If it produces more low clouds, as some models suggest it might, in some regions, under some conditions, the feedback is negative, dampening the warming. Which one happens determines the difference between a world that warms by 2 degrees over the next century and a world that warms by 5. Detectives looking at the paleoclimate record, the history of the Earth's temperature preserved in ice cores and ocean sediments, and the chemistry of ancient rocks, revealed that the climate system has, in the past, has crossed thresholds beyond which the feedbacks became self-sustaining, driving the climate into a radically different state from which recovery, on human timescales, was impossible. The most dramatic of these tipping points is called a snowball Earth event, a period occurring at least twice in Earth history, most recently approximately 635 million years ago, when the planet's ice albedo feedback, the same reflective cooling mechanism that makes clouds cool the planet, ran away completely. It began with cooling, perhaps triggered by changes in solar output, or by the position of the continents, or by volcanic eruptions that altered atmospheric chemistry. The cooling caused ice to expand from the poles toward the equator. Ice, like cloud, reflects solar radiation. More ice meant more reflection. More reflection meant more cooling. More cooling meant more ice. The feedback was positive. The loop was self-reinforcing. And it ran. Within, geologically speaking, a very short period, perhaps tens of thousands of years, which is an eye blink in Earth time, the feedback drove ice coverage from the poles all the way to the equator. The entire surface of the planet froze. The oceans were covered by ice estimated to be between 1 and 3 kilometers thick, thicker than the current Antarctic ice sheet over most of its area, covering tropical regions that today receive the most intense solar radiation on the planet. The equatorial ice surface reflected approximately 60% of incoming solar radiation back into space. The planet's average surface temperature dropped to approximately -50 degrees Celsius. -50. The temperature at which exposed skin freezes within seconds. The temperature of the coldest days ever recorded in Antarctica, as the average surface temperature of the entire planet, including the tropics, for approximately 10 million years. 10 million years of a frozen Earth. 10 million years during which the water cycle, the evaporation and cloud formation and rain and river and glacier cycle we have been following tonight, effectively stopped. The oceans were sealed under ice. Evaporation was suppressed. Cloud formation dropped dramatically. The sky above the frozen planet was clearer than at any point before or since. A clear sky above a world that was dying of cold. The clarity itself a symptom of the catastrophe, the absence of cloud evidence that the engine of the water cycle had been frozen into silence. And yet life survived. Detectives looking at the geological record of Snowball Earth revealed the evidence of life persisting through the freeze in the thin strip of ice-free water that may have existed near hydrothermal vents on the ocean floor. The same deep, dark, chemically fed ecosystems we encountered in other contexts. Organisms that did not depend on sunlight or cloud or rain or any of the surface processes that the ice had silenced. Life in the dark. Life on chemistry alone. Life enduring in the only place the cold could not reach. The deep, warm, volcanically heated water at the bottom of the frozen ocean. The same patience we have encountered everywhere. And after 10 million years of frozen silence, the catastrophe reversed itself. Not because the feedback loop was broken from outside, because the Earth's own geology continued working beneath the ice. Volcanoes continued erupting. Carbon dioxide continued accumulating in the atmosphere, because there was no rain to wash it out, no ocean to absorb it, no biological activity on the surface to process it. The carbon dioxide built up, decade by decade, century by century, million year by million year, until its greenhouse warming effect was powerful enough to overcome the reflective cooling of the ice surface. And then the ice began to melt. And as it melted, the albedo dropped. Less ice meant less reflection. Less reflection meant more warming. More warming meant more melting. The feedback that had frozen the planet now ran in reverse, a deglaciation so rapid, in geological terms, that some researchers believe the transition from fully glaciated to fully ice-free may have occurred within centuries or even decades. The frozen ocean surface, sealed for 10 million years, broke open. The water cycle restarted. Evaporation returned to the ocean. Clouds reformed above the warming surface. Rain fell on bare rock for the first time in 10 million years. The sky came back. And in the geological layers immediately above the snowball Earth deposits, In the rock record laid down in the first million years after the deglaciation, detectives found something that has been called the most dramatic biological explosion in the history of life on Earth. Complex multicellular organisms, appearing suddenly and in extraordinary diversity, filling the ecological space that the long freeze had cleared. As if the catastrophe itself, the 10 million years of frozen silence, had been, in some sense, a preparation. A clearing. A long, cold pause before the most creative period in the history of biology. The catastrophe made space for what came next. This is the pattern the Earth returns to, again and again, across 4.5 billion years of catastrophe and recovery. The rules change. The feedbacks run. The system tips into a state that looks, from inside it, like an ending. And then the geology continues. The chemistry accumulates. The threshold is crossed in the other direction. And life, patient, diverse, endlessly inventive life, fills the space that the catastrophe created. Your own existence is downstream of at least 2 snowball Earth events. The complex multicellular life that exploded after the last deglaciation is the lineage that eventually produced every animal on Earth, including every ancestor you have ever had. The catastrophe that froze the planet for 10 million years was a necessary predecessor to the biological diversity that made you possible. You are here because the sky changed the rules, and because the sky changed them back. Hold that thought now. Not urgently, not anxiously, but the way you hold something that is simply true and large and worth knowing. The system that is above you tonight, the clouds assembling in the dark, the water cycling through its ancient loop, the atmosphere balancing its competing effects of reflection and retention, has been through worse than anything currently happening to it, has been frozen solid, has been cleared of cloud entirely, has run its feedbacks to their most extreme conclusions and then, driven by its own geology, reversed. It is a system that contains, within itself, the mechanisms of its own recovery, not on human timescales, not within any time frame that is comfortable or convenient for the species currently depending on it. The Earth's recovery from a snowball event took 10 million years. The recovery from the last major mass extinction took several million years. The patience of the planet's self-correction is not the patience of a decade or a century. It is the patience of deep time. The same patience that built the clouds, and built the water cycle, and built the conditions for life. But it is there. The mechanism exists. The chemistry continues. The geology does not stop because the surface is in difficulty. Beneath whatever is happening at the surface, beneath the warming ocean and the shifting cloud patterns and the retreating glaciers, the mantle is still moving. The volcanoes are still processing carbon. The rocks are still weathering. The deep ocean is still absorbing. The planet is still, in its slow and patient way, working on the problem. It has always been working on the problem. And tonight, above you, the cloud is part of that work, reflecting its percentage of solar radiation, trapping its percentage of outgoing heat, maintaining, imperfectly and dynamically, and with all the uncertainty that makes it the hardest variable in climate science, the balance that keeps the surface of this planet in the narrow temperature range where liquid water exists and complex life is possible. The cloud is not decoration. It is the mechanism. And it is, right now, in the dark above your roof, doing exactly what it has always done. Continuing. There is water in you right now that has been a cloud. Not as a metaphor. Not as a poetic reach towards something that sounds meaningful in the dark. Literally, chemically, in the specific water molecules currently circulating through your bloodstream and filling your cells and forming the moisture on the surface of your lungs with every breath. Some of that water has, at some point in its history, been lifted from the surface of the ocean by solar energy, carried upward through the atmosphere on a column of warm air, cooled to its dew point, condensed around a particle of dust or sea salt, and existed, briefly, as a droplet inside a cloud. Some of it has been rain. Some of it has been snow. Some of it, a fraction so small it cannot be calculated with certainty, but also cannot be dismissed, spent time compressed inside a glacier, locked in ice for thousands of years, before meltwater carried it to a river, that carried it to an ocean, that evaporated it back into the atmosphere, that condensed it back into cloud, that rained it into a watershed, that fed a river, that was drunk by an animal, that was eaten by another animal, across a chain of consumption, and excretion, and evaporation, and condensation so long and so tangled that tracing any single water molecule back through its complete history is, practically speaking, impossible. But the journey happened, is happening. Every water molecule in your body is in transit. It arrived in you through food and drink, and the absorption of moisture through your skin, and the water vapor in every breath you have taken. It will leave you through sweat and breath, and the slow biological processes that return organic material to the soil. And when it leaves, it will continue. It will evaporate from the soil surface. It will be taken up by a plant root and transpired through a leaf. It will reach the atmosphere and rise on a warm air current and cool to its dew point and condense around a particle and become, again, a droplet in a cloud. The water does not end with you. You are a stop on a journey that began before the earth had continents and will continue after the last human being has returned their water to the ground. The molecule is older than life. It arrived on this planet, most likely, inside a comet or an asteroid, delivered to the early Earth during the period of heavy bombardment 4 billion years ago, when the inner solar system was still being cleared of the debris left over from its formation. It has been cycling through the Earth's water system ever since, through every ocean that has ever existed, through every glacier, through every cloud, through every raindrop that has ever fallen on every landscape in 4 billion years of weather. And tonight it is in you, resting. Detectives looking at the isotopic composition of water molecules in human tissue revealed that the specific ratio of hydrogen and oxygen isotopes in a person's body water carries a chemical signature of the water sources that person has consumed over the course of their life. Water from different geographic regions has different isotopic ratios, shaped by the history of evaporation and precipitation and glacial storage that the water went through before it arrived at that location. The water in your body carries, in its chemistry, a faint record of where you have lived and what you have drunk. A record written not in memory, but in molecular ratio. Not a story you can tell, but a signature that a careful instrument can read. You carry the geography of your life in your water. And your water carries the geography of the Earth, the specific ocean temperatures and atmospheric circulation patterns and glacial histories that shaped the isotopic composition of the water that fell as rain in the places where you have lived. The cloud that rained on your hometown, or the glacier that melted into the river that fed the reservoir that supplied the pipes that delivered the water to your glass, left its signature in you. The sky wrote itself into your body, one water molecule at a time, across every day of your life. You are, in the most literal chemical sense, a record of the weather. Now follow that thought in the other direction. Not backward into the history of the water already in you, but forward, into the water you are currently returning to the world. Right now, as you breathe, you are exhaling water vapor. Every breath out carries moisture from the surface of your lungs into the air around you. A resting adult exhales approximately 300 milliliters of water per day through breathing alone, roughly the volume of a standard can of fizzy drink, released into the atmosphere as invisible vapor across the course of a day and night of normal breathing. 300 milliliters of water every day, just from breathing. That water enters the air around you. It mixes with the atmosphere. It joins the 430 cubic kilometers of water the ocean contributes to the atmosphere every day, a number so large it makes your 300 milliliters seem negligible. And it is negligible, arithmetically. Your contribution to the water vapor content of the atmosphere is, in absolute terms, vanishingly small. But it is not zero. The water you exhale tonight will mix with the atmosphere. will rise on warm air currents, will cool to a dew point somewhere above a landscape you may never see, will condense around a particle of dust and become a droplet in a cloud that forms tomorrow morning above a place you have never been. And that cloud will reflect some percentage of tomorrow's solar radiation back into space, will trap some percentage of tomorrow's outgoing infrared radiation, will contribute, in its infinitesimal way, to the temperature balance of the planet on that day. Your breath is part of the weather, has always been part of the weather, will continue to be part of the weather long after you are no longer breathing, because the water will continue, cycling through its ancient loop, and the carbon in your exhaled breath will continue, cycling through its own loop, and the heat your body generates will continue, dissipating into the air around you and rising into the atmosphere, and contributing to the convective currents that build the clouds that make the rain that falls on the ground that feeds the rivers that reach the ocean, that evaporates back into the air. Nothing you contribute to the atmosphere is lost. It simply continues. Detectives looking at the history of the Earth's atmosphere revealed something that sits quietly at the center of everything we have explored tonight. The oxygen you are breathing right now, the 21% of the atmosphere that your lungs are extracting from the air with every breath, the oxygen that is, at this moment, being carried by your red blood cells to every tissue in your body, was produced by photosynthesis, by plants and algae and cyanobacteria, converting water and carbon dioxide into oxygen and glucose, releasing the oxygen as a byproduct into the atmosphere. The oxygen in the atmosphere is a waste product of the water cycle. It was produced when water molecules were split by solar energy inside photosynthetic organisms, the same solar energy that drives evaporation, that powers the updrafts, that builds the clouds. The sun splits water into hydrogen and oxygen. The hydrogen is used to build organic molecules. The oxygen is released. It accumulates in the atmosphere. And animals, including you, evolved to use that accumulated oxygen as the fuel for their metabolism, completing a loop that connects the water cycle to the atmosphere to the biology of every oxygen-breathing organism on Earth. You breathe the sky's water. The sky breathes your water. The loop has been running, in this form, for approximately 2.5 billion years, since the cyanobacteria first began releasing oxygen into an atmosphere that had previously contained almost none, transforming the chemistry of the air so completely that most of the organisms that existed before the change were poisoned by it. The Great Oxidation Event, the largest single transformation of the Earth's atmosphere in its history, driven by microscopic organisms in the ocean, releasing oxygen as a byproduct of splitting water molecules with sunlight. The atmosphere you are breathing tonight is the legacy of that transformation, is the accumulated byproduct of 2.5 billion years of photosynthesis, is the result of trillions of organisms in the ocean and on land splitting water molecules and releasing oxygen, day after day, across a time frame that makes all of human history look like the final second of a very long film. You are breathing the exhalation of 2.5 billion years of life. Let that move through you now, not as an intellectual proposition to be evaluated, but as a physical fact to be felt. The way you feel the weight of your body against the surface beneath you, the way you feel the slight expansion of your chest with each breath in and the slight release with each breath out. The air entering your lungs right now has been produced by life, has been cycling through the atmosphere and the ocean and the bodies of living things for longer than complex life has existed, has been breathed by every air-breathing organism that has ever lived on this planet, every dinosaur, every early mammal, every ancestor of yours across 2.5 billion years of biological succession. The breath you are taking right now has been taken before, many times, by many things, by organisms that had no name for what they were doing and no awareness of the sky above them and no concept of the cloud or the water cycle or the ancient loop of evaporation and condensation and rain that was, even then, cycling above them in the same patient way it cycles above you tonight. They breathed. They returned their water and their carbon to the world. They continued the chain. And eventually, across an unimaginable number of generations of continuation, the chain reached you. lying still, breathing, contributing your small, precise, chemically specific portion of water vapor to the atmosphere above you, building, without knowing it, the cloud that will form tomorrow. If this journey has been useful to you tonight, if this slow hour of water and sky and deep time has helped the weight of the day settle into something you can finally put down, then I would gently invite you to subscribe, or to leave a thought below about whichever part of this stayed with you longest. It helps other people who are lying in their own darkness, also trying to let the noise of today soften into the quiet of tonight, find their way here, one breath at a time. And if sleep is still arriving slowly, if there is still some part of the day that has not yet released its hold on you, there is another journey waiting, another corner of the natural world, another piece of deep time told at this same unhurried pace, in this same quiet voice, ready to carry you somewhere ancient and patient and larger than whatever is still asking for your attention. It will be there when you need it. But for now, feel the weight of your body where it meets the surface beneath you. Notice that the surface holds you without effort, without negotiation, without any awareness of the weight it is bearing. The ground beneath you, beneath the floor, beneath the foundation, beneath the soil, goes down through layers of rock and sediment and compressed geological time, all of it between you and the warm interior of the planet, all of it holding you up, all of it the residue of the same ancient processes that built the clouds and filled the oceans and produced the oxygen you are breathing and cycled the water now resting inside your cells. You are held by everything that came before you, by 4.5 billion years of the Earth doing its patient work, by the cloud above you, assembling its droplets in the dark, reflecting tomorrow's sunlight back into space, releasing its rain onto landscapes that are sleeping the same sleep you are approaching now. Allow your shoulders to soften, the way a cloud softens at its edges when the updraft slows and the droplets begin to disperse back into vapor, not disappearing, not ending, just changing form, releasing the shape they held and becoming something lighter and less visible and less defined. Allow your jaw to unclench. Allow your hands to open. Allow the thoughts that are still moving at the surface of your mind to drift down, slowly, the way water vapor drifts upward, without effort, without direction, simply following the gentle gradient from where it is to where it is going. Your breathing is already slower than it was when we began. Your body already knows what to do. It has always known. The cloud above you is building in the dark. The water in your cells is resting. The oxygen you breathe is 2.5 billion years old, and it is here, in this room, in your lungs, doing the quiet work that keeps you alive while you sleep. Nothing needs solving tonight. Nothing needs remembering. The sky is working. You can rest. Allow the dark to hold you the way the atmosphere holds a cloud, completely, without effort, without any awareness of what it is holding, simply providing the conditions in which something beautiful can exist. The water will continue. The cloud will continue. The breath will continue. Let yours slow now. Let it deepen. Let it find the pace it finds when you are finally, completely, without reservation, still. Sleep well, and good night.